All right, kids, it's time for discussion 9.2, all about acids and bases. So we will come to this at the end. No sense giving a pretest if I'm making a video, but we'll do that in class. All right, so acids and bases are essentially opposite of each other. So there's ways we can tell them apart. So for acid and base, the feel, for acid, it's just like water, okay? And bases are slippery. So if you wanted to tell the difference between an acid and a base, dip your finger in it and rub them together. If you rub them together and it feels slippery, that tells you it's a base. We wouldn't do this in the chemistry lab, but we could also taste them. Acids, like lemon juice, have a sour taste. Bases have a startlingly bitter taste. So taste it. Taste sour, acid. Taste bitter, it's base. We can also test between an acid or base by reacting with a metal. Acids will react with metals, and bases generally will not react with metals. So if you had to identify a compound as being either an acid or a base, chuck a piece of metal in it. If you see bubbling happen, it's an acid. If you don't, it's a base. Another way to tell acids and bases apart is to use things called acid-base indicators. Litmus and phenolphthalein are both acid-base indicators. Now, what an indicator does is it changes color. It'll show one color in an acid and another color in a base. So we just use a little bit of those compounds to tell what we've got. Litmus paper in acidic conditions will show a red color. In basic conditions, it will show a blue color. Phenolphthalein we've actually worked with this year. In acid, it's colorless, so we could say it's clear, but in base, it turns a really nice pink color. Now finally, electricity, or whether or not the solutions are conductive, we can't really use that to tell apart an acid or a base because acid and bases both produce ions. So they are conductive. Yes and yes. Okay? Now let's actually talk a little bit about what acids and bases are. Acids are any, I'm going to use this term species. Just in case you're unfamiliar, species is just the thing we're talking about. So in chemistry, a species can be talking about atoms, ions, or molecules. So it's any atom, ion, or molecule that when dissolved in water will increase the concentration of hydrogen ions. When dissolved in water, I'll just say H2O, will increase the concentration of H+. We show that H+ by putting the symbol in square brackets. Those square brackets mean the concentration of H+. In fact, when we put any symbol for an element, compound, or ion in brackets, what we are showing is the concentration of that ion. So examples of acids, well, in order to be an acid, you have to be able to increase the concentration of hydrogen ions when dissolved in water. So they all have to have H. Some examples: hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, hypochlorous acid, and so forth. Now, you don't need to know the names of these acids, but you have to know they're all acids. It's really easy because they all feature the same element in front of their formula, and that is H. If you see H in front, that tells you it's an acid. So bases, and I'll do this all in blue since acids make red and bases make blue. Bases are any species that when dissolved in water, same words as up above, so I'm just going to use quotes, any species that when dissolved in water increase the concentration of hydroxide ions. So in order to be a base in this definition, if you take the next course, you'll learn about other definitions of acid and base, but they have to feature hydroxide ions. So examples of bases, sodium hydroxide, potassium hydroxide, calcium hydroxide, iron 3 hydroxide, etc. Look at what these all have in common. Their formulas all end in OH. All right, so pH. Most of you are familiar with pH. You're probably not familiar with what it is. Well, pH is important to use really because it makes it easy to determine or to express the concentration of acids or bases. A lot of times the concentrations are really small. If we look at this concentration here, it's 1 times 10 to the minus third, so that's 0.001 molar, very dilute. So pH just makes it easier for us to work with. Now, pH, before we can define what pH is, let's go ahead and define what P is. P in math stands for the negative log base 10. So you don't have to know about logarithms necessarily to work with this. It's for you guys really, it's just going to be a button in your calculator. But whatever comes after the P in the formula of pH is the negative log of that thing. So pH is defined as the negative log of hydrogen ion concentration. If you need to calculate pH and you're given hydrogen ion concentration, all we have to do is punch it into our calculator, hit negative log, and then whatever the concentration is. Now, because this is a logarithmic scale, we can also solve for H+. If we know the pH and want the hydrogen ion concentration, we just have to take 10 to the negative pH. So, for example 3 here, if I take, this is my hydrogen ion concentration, so pH is just going to be negative log of 10 to the minus third, which equals 3. For hydrogen ion concentration of 1 times 10 to the minus 11, pH will be the negative log of 10 to the minus 11, which is 11. Now, if it's ever 1 times 10 to the, your pH will just be the exponent that's on the 10. So 10 to the minus third, pH was 3. 10 to the minus 11, pH was 11. And now if we want to calculate H+, to get H+, I just do 10 to the minus pH, so 10 to the minus second here. For a pH of 12, concentration of hydrogen ions would be 10 to the minus 12. All right, so POH, well, P means negative log of OH, so POH is just the negative log of hydroxide ion concentration. And if I want to solve for hydroxide ion concentration, that will just be equal to 10 to the negative POH. So just like up above, if we have a hydroxide ion concentration of 1 times 10 to the minus 6, to get the POH, it's just negative log of hydroxide ion concentration, which in this case would equal 6. If I want to get the hydroxide ion concentration from the pH, it'd just be 10 to the minus POH. So if the POH is 9, it's 10 to the minus 9. Now there's a really nice relationship between pH and POH. If you know one, you know the other. Because if you take pH and add it to POH, they'll always add up to 14. That means if your pH is 5, then your POH must be 9. They will always add up to 14. So really quickly, let me do a little trick here. If we got the pH and it's 6, that means the POH must be 8 because they'll always add up to 14. If the POH is 2, then the pH must be 12. All right, so here we have the little tricky thing because we're given hydrogen ion concentration and asked for POH. Why don't you pause the video for a second and see if you can work this one out on your own. All right, so the beautiful thing about these relationships, if you know any one of our variables, so if you know hydrogen ion concentration, hydroxide ion concentration, pH, or POH, you can determine the rest of them. So if our concentration of hydrogen ions is 1 times 10 to the minus third, well, the negative log of 10 to the minus third is 3. That means the pH is equal to 3. Well, since the POH and the pH add to 14, that means my POH must be 11. And if I know the POH, I know the concentration of hydroxide ions is just 10 to the minus POH, so that would be 10 to the 11. If you know any one of these factors, you can calculate all the rest relatively easily. All right, so let's go ahead and talk about the relationship between hydrogen and hydroxide ions in water. So this word dissociation just means to break apart. So water will spontaneously decompose into hydrogen ions and hydroxide ions. Now, in pure water, the concentration of hydrogen ions must be equal to the concentration of hydroxide ions. That's because if you had a surplus of hydrogen ions, you would be acidic. If you had a surplus of hydroxide ions, you would be basic. But if they're equal, they are neutral. So the relationship between them is really easy to work out, like I just told you. If the hydrogen ion concentration is 1 times 10 to the minus 10, well, if these things are going to be equal, I'm sorry, I'm not doing this properly, then they both have to be 1 times 10 to the minus 7, their concentration. So I know if I take 1 times 10 to the minus 7th and square it, I get 1.0 times 10 to the 14th. So whenever we multiply things together like this, scientific notation, our exponents just add. So for this one, if my hydrogen ion concentration is 1 times 10 to the minus 10, the exponents, have to add up to a total of 10 to the minus 14. So my hydroxide ion concentration must be 1.0 times 10 to the negative 4th. Now, you could also go the long way. If H plus is 10 to the minus 10, that means my pH is 10, which means my POH must be 4, which means my concentration of hydroxide must be 10 to the minus 4, which is what we see there. All right, so the ratio of hydrogen ions to hydroxide ions will tell us if we have an acidic or basic solution. So acids will have a surplus or extra hydrogen ions in it. Bases will have a surplus of hydroxide ions. So if the concentration of hydrogen ions is greater than 1 times 10 to the minus 7th, that means you have an acidic solution. And if it's the hydroxide ion concentration is greater than 1 times 10 to the minus 7th, then that means you have a base. So a solution has an H plus concentration of 1 times 10 to the minus 11th. Is that acidic or basic? Well, that is smaller than 1 times 10 to the negative 7th. So, hold on a second. That means our pH would be 11. That means our solution would be basic. If a solution has a hydroxide ion concentration of 10 to the minus 2, that means the POH is 2, meaning this is also basic. Oh! I'm sorry, I got screwed up here. This would be basic. The first one is correct, but I didn't see that that was hydrogen ion concentration. That's why I paused. If the hydrogen ion concentration is 1 times 10 to the minus 11th, then we saw in the previous slide that the hydroxide ion concentration is 10 to the minus 3rd, which is a greater value than 10 to the minus 7th. So here we have a solution with a hydrogen ion concentration of 10 to the minus 4. That means my pH is 4. 10 to the minus 4 is greater than 10 to the minus 7, so that means this solution would be acidic. I know that wasn't smooth, but at this point in the lesson, I don't want to go back. All right, so neutralization reactions are reactions of acids and bases. Now, these are double replacement reactions. So in these reactions, the H and the OH combine to make water, HOH. The cation from the base and the anion from the acid come together to make a salt. In this case, the salt that's made is actually table salt. So for hydrochloric acid and sodium hydroxide, we would make water and sodium chloride. For hydrochloric acid and magnesium hydroxide, we would make water and magnesium chloride. Now we're going to go ahead and balance this. I'm going to do a little bit of that and a little bit of that, and that should do it. Yes, okay. So neutralizations will always produce two types of products. One will always be water, and we see that here. The other will be a salt. Now remember, a salt is what we refer to as how we refer to an ionic compound. We're not saying salt is always going to be sodium chloride. That's just table salt. Salts are ionic compounds, and that's what we see there and there. All right, finally, I want to talk about titration. Titration is a method used to determine the unknown concentration of an acid or a base by using a known volume and concentration of a known acid and base. I never say that good. So here is our titration formula. It's N subscript A times M subscript A times V subscript A, and that will be equal to N subscript B times M subscript B times V sub B. So it's very similar to our dilution formula. We just have this added factor. So let me go ahead and define all the terms, and then we will do some examples. So Na is the number of moles of H plus per mole of acid. Basically what that means, it's the number of H's in the formula for the acid. So for examples of the Na factor, HCl, Na would be 1 because the formula has 1 hydrogen. Sulfuric acid, which is H2SO4, that Na factor there would be 2 because the formula has 2 hydrogens in it. Ma is just the concentration of acid, capital M is molarity. Va is the volume of the acid. I shouldn't need to define those terms anymore. Nb is the number of moles of hydroxide ions that you have. So for sodium hydroxide, that Nb factor would be 1 because there's 1 hydroxide ion. For calcium hydroxide, that Nb factor would be 2 because there's 2 hydroxide ions and so forth. So this is a device called a burette. We have down here an Erlenmeyer flask. When we do a titration, we put our unknown concentration acid or base in there, and we fill the burette with a base of known concentration. We then see how much base it takes to neutralize the acid, from which we get the volume of the base. The volume of the acid we know because we measure it before we pour it into the flask. So we'll know the identity of the acid, we'll know the volume of the acid, we'll know the identity of the base, the concentration, and the volume used in the base. The volume used comes from the burette to calculate the unknown concentration. So let's go ahead and look at a couple of examples, and then this video will be done. First one says, what is the molarity of a KOH solution if 25 milliliters of it is neutralized by 31.7 milliliters of a 0.1 molar nitric acid solution? So here is my base, here is my acid. Let's go ahead and define our terms. It's asking me for the molarity of KOH. So M sub B, the molarity of base, is my variable. It tells me it's KOH. There's only one OH in that formula, so my NB factor will be 1. If 25 milliliters of it is the base, so this is my volume of the base. Don't forget to convert to liters by dividing by 1,000. That means the decimal place moves over 3 places to the left. It's neutralized by 31.7 milliliters of 0.1 molar nitric acid. So this here is my volume of my acid. This here is my concentration of my acid. And because there's one H in nitric acid, that tells me my Na factor will also be 1. Now it's just a matter of plugging the numbers into the equation and solving. So here is the equation. Na is 1 times Ma, which is 0.100, times Va in liters is 0.0317, equals Nb, which is 1, times Mb, which is our variable, times a Vb, which is 0.0250. Now it's just a matter of solving for the variable. So this is going to be 0.1 times 0.0317 divided by 0.025, and that gives me a concentration of my base of 0.127 molar. Huzzah. Why don't you guys try the next one all on your own? So pause the video, see if you can figure it out. All right, so this one, we got a 25 milliliter sample of H2SO4. Now, I recognize the H in front is acid, so this must be the volume of acid. Now, this is H2SO4, so my Na factor here will be 2. It says it's neutralized by 27.4 milliliters of 1 molar KOH. So this here must be my volume of base, and this here is my concentration of base. Now this is KOH, so my NB factor will be 1 because there's one hydroxide ion. So plugging into the same equation as up above, Na in this case is 2 times Ma, which is what is the concentration of the acid? That's our variable, Ma, times Va, the volume of the acid, which is 0.0250 liters, equals the NB factor, which is 1, times the volume of, or times the concentration of the base, which is 1.00, times the volume of the base, which was 27.4 milliliters, or 0.0274 liters. Now we're just going to solve for the concentration of the acid. It will be 0.0274 divided by 2 divided by 0.025, and I got 0.548 for my concentration of acid. Not feeling all that hot today. I think I'm going to have to go home and take a COVID test, unfortunately. I don't want to. All right, so now let's come back to this slide from the beginning. Phenolphthalein turns it pink. Base. pH greater than 7. Base. Reacts with metal to produce hydrogen gas. Acid. Turns blue litmus paper red. Turns it red. It's an acid. Feels slippery. Base. Tastes sour. Is an acid. Contains hydrogen ions, is an acid, and sodium hydroxide is an example of a base. If you can go through that, you're good to go. All right, young ones, have yourselves a lovely, and I'll see you in class.